Hello everyone, Assalamu alaikum. My name is Jahid. Today I will talk about our presentation tax 5. So this is Computer Network MTN3023. So this is tax 5 and this tax we will submit it to Dr. Suhaslan bin Suhaimi. So this is my group member is here. And then today I will talk about some parties here. So the first part is how our transmission conflict in broadcast link resolved. The transmission conflict is a broadcast link resolved by using nodes. If an error occurs, the data link layer notified higher level protocol that something has happened to the physical links. Frame sequencing capabilities within the data link layer permit the receiving device to record a frame that might have been transmitted out of sequence. The data link layer verifies the packet is unpaired, and the data link layer also manages follows by enabling device on a link to detect cognitions. Neighborly device then transmit cognitions information so traffic can be routed accordingly. If the part of the frame was not lost and during transmission, the link layer protocols of the receiver would seen that and would request data transmit from the sender. And network addressing are the designed to be unique identifies across the network, although some network allowed for local private and addressing or locally administrated addresses that might not be unique. So this is a network layer addressing in general of two parts: network address, host node, and address. So network address used by the router to identify a path within network cloud and or a destination network. Host or node addressing identify the specific port of our device. So this is a network layer addressing. So data, the first step is a application segment and packet go to data link to physically routing and go one by one. Packet segment is data is there, transport, and the application is there. So data link layer takes the packet from the network layer and back it into the frame. The header in this layer provide the source and destination MAC address. They work by guiding the traffic to a destination based on a MAC addresses. The MAC address is a unique series of number and letter used to identify and certain network card. A switch can direct traffic to the correct computer only if it's aware of what port the computer and network card attached. This is done by the computer presenting the MAC address from its network card to the switch when it first come online. So this is all about for me, and thank you so much for listening the presentation, and thank you so much again.
So I will present about the issue how packets are sent across the individual link that make up the end-to-end communication path. So datagrams are transport across the individual link in the layer from host A to host B. So the TCP that run on both end hosts use the end-to-end communication to make sure the host B receive datagram from host A. End-to-end communication will leave only the two hosts that involve to communicating each other. For example, host A want to send data to host B. the data maybe can face error in the IP. So TCP of host B will send message that they don't receive the data. Host A will resend it. So as the conclusion, end-to-end communication will avoid error in the data transfer, and this will increase the reliability of the data transfer. Next, how the network layer datagrams encapsulated in the link layer frames for transmission over a single link. We can see this diagram. I will explain it from the application layer to the physical layer. So first, what is data encapsulation? Data encapsulation is designing a modular communication by taking data from one protocol and translate it to another protocol so that the data can be sent over the network and transmit to their destination. Data encapsulation occur in each layer from application layer to physical layer. We can see from the diagram before. So the data in PC1 in the application layer will across to the transport layer. So in the transport layer, it will add a header TCP or UDP to the data, and this is called a segment. Then this segment is passed down to the network layer. Another header is added. It is a IP protocol. Then it is called a packet. Then this packet will be sent to the data link layer. In this layer, not only a header is added, but also it will add a trailer. Now this packet will transform and we call it a frame. So lastly, the frame will be sent to the destination in the physical layer PC2. So that's all how the data encapsulation occur from each layer, that is application layer, to the physical layer.
All right, so today we're gonna see the difference between router and switch. I'm sorry. So, what is a router? Let me drag this here. All right. So, a router forwards data packets between computers, which means the router can forward data packets from PC, for example, PCA to PCB. All right. So that's the main function of the router. The router routes data from one network to another and connects different networks together. Okay, as you can see here, I will put it as a PCA. This one is PCB. Oh, I'm sorry. You can just imagine that I'm that this PCA and there is a PCB. So with the help of router, we can connect them both. All right. So PCA belongs to a network A and PCB belongs to network B. So with the router, network A and network B are connected with each other with the help of via the PCA and PCB. All right, so switch uses IP address for data transmission. Yes. All right. Whereas switch uses packet switching to receive, process, forward data to destination device. And switch also creates a network by connecting several devices together and allows the exchange of data within its own network, or as we prefer to call, local area network, LAN. Okay. So what do I mean by that is switch connects. For example, we can see in the diagram in the top right corner, PC1, PC2, PC3, PC4, PC5, and connected to the switch. This means that the switch can connect PC1 and other PCs together, and that creates a local area network. All right. So another point is switch uses MAC address. I'm sorry, for data transmission. So that's the difference between a router and a switch. So you can see that there is that we cannot see that the router and switch doesn't have a what we say that we cannot distinguish it by far, because it has very little, not very little, just a little bit of difference. All right, okay. All right, so for the link layer protocols. So for the link layer protocols, the issue that have come up is, do we have to use different link layer protocols in a different in no not I'm sorry, not a different link, just a link in a transmission communication path, exactly, precisely. So okay, all right, here I'm gonna see here. So along the communication path, different link layer protocols are used in the different links. Why? As you can see here, we in the OSI model, we have different layer 1 until layer 7. So why do I say that we have to use different link? No, we don't have to, but it it already uses different protocols. For example, in layer 2, this data link phase, framing protocols will be used. For example, there is a packet coming through here, and this physical they uses, I'm not sure what the protocols use here, but when the physical path here, a packet goes through to the layer 2, which is data link, they will use it uses framing protocols to put what we say IP address or MAC address to identify, no, not to identify, to give an identity to the packet. All right. Then when it reaches to layer level 3, error detection protocols will be used. So we can see that the protocols that are used will be changed according to the layer that the link is being processed at. Link, or what do you say, packets. Okay. So that's all. Thank you.